Dear friends, let us see what are the application of integrations. In this chapter, we are discussing the geometrical applications of integration, which is named as area under curves. Let us see. Let us start with a simple example. Consider this straight line, which is bisecting first and third quadrant. Can you say what is the equation of this line? Obviously, it is the graph of identity function whose equation is y is equal to x. Consider such a triangle whose one of the vertex is at origin and hypotenuse is along the line y is equal to x. Can you directly say what is the area of this triangle? Yes, it is a right triangle whose area is half base into height. Base is 4. What about the height? Yes, the equation is y is equal to x. So at the point 4, height must be 4 itself. Therefore, let us see the area of this figure. What is the area of triangle in this figure is half base into height, which is half times. We saw that base is 4, and using the equation y equal to x, height also equal to 4, which results to 8 square units. Now let us consider an integral 0 to 4 y dx. What these 0 and 4 are? Did you observe? Yes, they are the first and last end points, means end points of the base, right? One of the end of the base is at origin and the other end at 4. Therefore, we consider the definite integral 0 to 4 y dx. What about it is equal to integral 0 to 4? Equation is given as y is equal to x. Therefore, it is 0 to 4 x dx. Integral of x, we know it is x square by 2. Between the limits 0 and 4, it is substituting upper limit first, 16 by 2 minus lower limit 0 is equal to 8 square units. What if we so is using the basic equation half base into height and using the integral, we got the same results. Therefore, we are equating the left side's area is equal to integral 0 to 4 y dx. Let us generalize this thing. Consider the graph of such a function y is equal to f of x. We are considering the extremities x equal to a and x is equal to b. Then what we are going for is the area under this function f of x from, what are the extremities? From x equal to a and x equal to b. We saw that it is given by integral a to b y dx. Y is actually f of x. Therefore, the area under this curve between the extremities x equal to a and x equal to b is given by integral a to b f of x dx. On the other hand, consider this graph. Consider such a graph along y-axis whose equation is x is a function of y. We are considering the extremities y equal to a and y equal to b. Then we are going to find the area under this curve up to y-axis between the extremities y equal to a and y equal to b. Can you guess what it will be? Yes, it is area is equal to integral a to b x dy. That is integral a to b f of y dy. These are the main two concepts in this chapter. We are going for one more result, area between two curves. So in the figure, you are given two curves. One is y equal to f of x and means up the upper curve we say, and the second curve y is equal to g of x. You can see the lower curve. The area between the curves is shaded. What about that area? We know the formula to find area under a curve up to an axis. So here up to x-axis, that means we will get to the area. Area is equal to, you can guess it as area under the upper curve. So you will get the full region up to x-axis. That area in white is to be subtracted. It is the area under lower curve or g of x. Therefore, the required area or the shaded area is given by area bounded by y equal to f of x. What are the limits between x equal to a and x equal to b? Minus area under the lower curve y equal to g of x, x-axis, and the lines x equal to a and x equal to b. How will you represent it symbolically? It is given by integral a to b f of x dx minus integral a to b g of x dx. Because since the limits of integration are same, you can consider it inside the same integral. It can be written as integral a to b f of x minus g of x dx. Let us go for some examples. Consider to find the area of a region bounded by the curve y square equal to 9x, x equal to 2, x equal to 4, and the x-axis under the condition it is in the first quadrant. What about the curve y square equal to 9x? You can see that x is linear, y is quadratic in the given equation. Definitely it represents a parabola. Which type of parabola? In this equation, x is linear. Therefore, this represents a parabola open towards positive x-axis, symmetric with respect to x-axis. Here is the graph for that. So the main step for this is reading, understanding the question, and draw the perfect figure for that. So here is our parabola y square equal to 9x. The extremities are shown x equal to 2 and x equal to 4. Since the area in first quadrant is demanded, we shade that portion only. Can you guess what that area will be? Yes, it is integral. What are the extremities? 2 and 4. So it is 2 to 4 y dx, integral 2 to 4. But y square is equal to 9x given. Therefore, y should be square root of 9x, which is 3 times root x dx. Solving 3 times root of x, integral x power 3 by 2 by 3 by 2 between 2 and 4, which is 2 times 4 power 3 by 2 minus 2 power 3 by 2, which is 2 times 8 minus 2 root 2, or it is 16 minus 4 root 2 units. Next example, let us see. Find the area of the region bounded by the ellipse x square by 4 plus y square by 9 is equal to 1. Let us draw the figure. Which type of ellipses? You can see x square by 4 plus y square by 9. Therefore, major axis is along y axis. So the figure is like this. Here is the figure for that. Ellipse, extremities minor 0 to 2, major 0 to 3. What about the area? In such questions, we can easily see that instead of finding the whole area, we will find, so you see, all the figure is equally distributed in all the 4 quadrants. So we will find the area of the shape in any one of the quadrant will get multiplied by 4. So what we are going for is x square by 4 plus y square by 9 equal to 1. Let us find y first, because the equation hints integral y dx implies y is 3 times the square root of 1 by x square by 4. Therefore, area is given by integral 0 to 2. We are taking along x-axis 0 to 2 y dx. Y is substituted 3 times root of 1 minus x square by 4. Multiplying by 4, it is root of 4 minus x square dx. Using the equation integral root of a square minus x square dx, which is x by 2 root of a square minus x square plus x by 2 a square by 2 into sine inverse x by a. Under the limits, you have the result as 3 pi by 2, which is the area of that shape, that region in first quadrant only. Therefore, area bounded by the ellipse is 4 times what we got, 3 pi by 2. Answer 6 pi units. So in case of such symmetric figures, you find the area of any one region multiplied by number of same regions. One more example, let us see here. Find the area of the region in the first quadrant, again restricted, enclosed by x-axis, a line x equal to 3y, and the circle x square plus y square equal to 4. Look at the circle, x square plus y square is equal to 4. It is a circle with the center at origin with the radius 2 units. What about the line x equal to root 3y? Definitely it will pass through origin and first and third quadrants. Let us see the figure. Here the figure for you. You have a circle and the line x equal to root 3y. The problem is in between the shaded figure in the first quadrant, there is a point of intersection between the circle and the straight line. So solve for it first. The point of intersection of the line and the circle in the first quadrant, when you solve, you will get it as root 3, 1. That means from 0 to O to C, that means from 0 to root 3, it is area under the line, plus from C to B, that is from root 3 to 2, it is the area under circle. Let us find first area of triangle OAB. Area of triangle OAB, it is same as area of OAC plus area of ACB, which is area of OCA. It is a right triangle, therefore definitely it is half base into height. Very directly you have area of OAC. The triangle, right triangle OAC is root 3 by 2. And let us go for the next area. Area of the region ABC. It is the area under the circle up to x-axis from root 3 to 2. That is area of that is integral root 3 to 2 y dx. Y is root of 4 minus x square dx. Using the same equation, square root of s square minus x square dx, we have pi by 3 minus root 3 by 2. Therefore, to find the area of the shaded region, we will add both the given resultant results, which is root 3 pi by 2 plus this one is, you will get pi by 3 units.